Okay, welcome to Unit 2. I think this is Lesson 5. In this lesson, we're going to talk about the chain rule for derivatives. And so we're going to find the derivative using chain rule and use some trig rules and some natural log rules as well. We've come up with a nice little set of shortcuts, but sometimes two functions are composed, and if you have two or more functions composed, then you have to use what we call the chain rule. And basically the chain rule says this: the derivative with respect to x is the derivative of the inner function times the derivative of the outer function if two functions are composed. So we have a composite function. Remember, this symbol represents a composite function. So we take the derivative of the inner function, we take the derivative of u with respect to x, and then we take the derivative of the outer function with respect to u. It will all make sense in a minute. Okay, so let's say we have this function. You have to see that this is a composition of two functions. The inner function is x squared minus 4. The outer function is the sine of, let's call this u. Okay? So what we're going to do is start by taking the derivative of the inner function, and of course the derivative of the inner function would be 2x. And then we take the derivative of the outer function, which would be the derivative of sine u. Well, the derivative of sine u, so this is derivative of the outer function, would be cosine of u. If I were to take the derivative of sine u, I get cosine of u. But what is u? U is x squared minus 4, so this would be 2x times cosine of x squared minus 4. So we go back and we substitute in that value for u. So we took the derivative of the inner function and multiplied it times the derivative of the outer function. Now, it's called the chain rule because we can do this multiple times. I want to give you an example. This actually are three functions composed. This could be written as the cosine of 3x and this entire quantity squared. So what we see is we have three different functions, the composition of three functions. The inner function is 3x, the outer function is cosine x, and the outer function is cosine squared. Okay? So we have to start by taking the derivative of the inner function, and this inner function is 3x. So what is the derivative of 3x? 3. The outer function is cosine of 3x. So what's the cosine of 3x? The cosine of 3x is negative sine 3x. And then the last one is this particular function where we have to use the power rule. So the power rule says we're going to bring down the 2, and you have to consider all of this as one thing. So this would be 2 cosine 3x. And of course, when we subtract 1 from the 2, we get just 1. So we can write this as negative 6 multiplying the 3 and the 2 sine 3x times cosine 3x. So let's do this a little differently. Let's say that we're still going to write it the same way. So we're taking the derivative of d dx and of this entire function cosine 3x quantity squared. Okay? So what we're going to do is we're going to let u equal to 3x. Give me another variable. Let's say b is equal to the cosine. So it would no longer be the cosine of 3x, it would be the cosine of u. And then c, let's let that equal to b squared, because cosine 3x is now b. So what we're doing is taking the derivative of each of these. So the derivative of 3x is 3. The derivative of cosine u is negative sine u, and the derivative of b is 2b. So now we're just going to replace everything with the x's. So this becomes 3 times negative sine. We're going back to everything in x's, so u was 3x, times 2b, and b was cosine of u, which is 3x. So as we take everything back in terms of x's, and you'll see that that gives us the exact same answer. So that's two different ways of doing it. This one's a little bit more difficult than the ones that we're going to do. But I just wanted to show you when we have to take the chain rule 3 times. You want to remember to use the chain rule. That is one of the biggest mistakes that is made on this test. Okay? So let's start. We have to look and see what is the inner function. And the inner function here is pi x. So I'm going to take the derivative of pi x. And the derivative of pi times x is simply pi. Then I want to take the derivative. Now this looks like u. So I'm taking the derivative of u. The derivative of sine u would be cosine u. But u is, you got it, pi x. Okay? So once again, we want to start by taking the derivative of the inner function. The inner function here is 4 minus x squared. So the derivative of that inner function is negative 2x. Then we want to take the derivative, so we want to look at this almost as if u to the 5th. So the derivative of that using the power rule is 5u to the 4th. But what is u? U is this inner function, so it's 5 times 4 minus x squared raised to the 4th power. And then, of course, we would multiply this out. I'm sorry, that should give me 10. So it's the negative 10x times 4 minus x squared to the 4th. So you kind of want to look at this. Let's rewrite this as 5 minus 3x quantity raised to the 1/2. You want to look at this is that you're taking the derivative of what's inside of here first, which is negative 3. Then we're using the power rule on this part. We're taking the derivative of the outer function, which we have to use the power rule. So we do 1/2. This is what we're taking. You have to look at this as an entire thing. So 1/2 times 5 minus 3x, and then we subtract 1/2 from that. And we subtract 1 from 1/2. So we can write this as negative 3/2, 5 minus 3x raised to the negative 1/2. Now, this may seem like we don't need to use the chain rule on it, but we do because we need to write this as t squared plus 3t minus 1 all raised to the negative 1 power. Okay? So once again, we have to take the derivative of the inner function, which is 2t plus 3. Make sure you put this in parentheses. Now the derivative of that outer function is simply multiplying by negative 1, and then this remains the same, and subtracting 1 from negative 1, which is negative 2. So I could write this as negative 2t plus 3 times t squared plus 3t minus 1, all raised to the negative 2 power. Of course, that can be written differently as well. I would suggest that you may pause this and try a few on your own and then come back and see the rest of them, okay? So what we want to look at with this, we want to write this as, this is 3, and then we have 2 minus 9x raised to the 1/4 power. And 3 is a constant, so it's not really changing anything, it just comes down. So I want to take the derivative of the inside first. So the derivative of 2 minus 9x is negative 9. Then the derivative of the outer function, we're going to use the power rule, so the 1/4 comes down. The 2 minus 9x remains the same, and then I subtract 1 from 4th to get negative 3/4. So I would, multiplying all this together, I get negative 27/4. 2 minus 9x to the negative 3/4. And if this were a multiple choice test, it could be written as negative 27 over 4 and the 4th root of 2 minus 9x quantity cubed. It can be written that way as well. Okay? E to the 2x, we're going to have to use the chain rule on this, so we always start with the inner function. The inner function is 2x, so the derivative of 2x is 2. And then the derivative of e to the 2x is e to the 2x. Yeah, that's it. That's your answer. Okay? Once again, take the derivative of the inner function. So we're going to start by taking the derivative of x squared plus 2x minus 4, which gives us 2x plus 2. And the derivative of the natural log, so we want to look at this as if it's u. So if u is equal to x squared plus 2x minus 4. And then we have the natural log of u. So the derivative of the natural log of u is 1 over u, but u is x squared plus 2x minus 4. Okay, for this one, let's see the whole picture. Okay, we have to write this as, anytime you have that square, you have to write this as 4 sine x quantity squared. This is another way of writing that. That makes it a little bit easier, because we can easily see the inner function here is sine x. So we would let u equal to sine x, and y then would equal to 4u squared, if you will. Okay? So then the derivative of sine x would be cosine x. The derivative of 4u squared would be 8u raised to the first power. Okay? But we have to remember u is sine x. So then we have cosine x times 8u, but u is sine x. So that would give us 8 cosine x sine x is the derivative. Okay. So once again, we have to remember what the derivative of cosecant is, and I know it's negative something. So we want to make u equal to cosecant x. So the derivative of cosecant x, the derivative of secant x is secant x tan x. So I think the derivative of cosecant x is negative cosecant x cotan x. Don't quote me on that. And then we have y is equal to the square root of u, and the square root of u is 1 over 2 u. So, and then we have to remember that u is cosecant x. So this will give me negative cosecant x cotan x over 2, and that should be u raised to the 1/2. Sorry, it should be 2 u's raised to 1/2. And in this case, u is cosecant, so it'll be 2 square root of, yeah. Okay? Now, this one is like the second one that we did at the beginning. It's got 3 functions nestled in here. So, we're going to let u equal to 3x squared plus 4x plus 1. Then let's say m is equal to the natural log of u. And then y is equal to the cosine of m. Okay? So we take the derivative of each of these. I'm just going to call it the derivative. So we take the derivative of each of these, so that gives us 6x plus 4. The derivative of natural log of u is 1 over u, and the derivative of cosine m is negative sine m. And then we multiply the three of these together, remembering that we have to go back to the u. So this becomes this, and m becomes this. Okay? So then we have 6x plus 4, you need parentheses, times 1 over u, which is 3x squared plus 4x plus 1, times negative sine of m, and m is the natural log of u, and u is 3x squared per 1. So this will be the sine of the natural log of u, which is 3x squared plus 4x plus 1. And then, of course, we can simplify all of this. The only really simplifying I would do would probably say this is negative 6x plus 4 over 3x squared plus 4x plus 1 times the sine of the natural log of 3x squared plus 4x plus 1. That's pretty much all the simplifying that we can do. Okay, so I want you to complete page 26 in your packet. It's a review. I think it's a free response question. And then I want you to try some problems out of the textbook. Okay? And as always, text me if you have any questions.